Okay, I'd like to welcome everybody. For those that don't know me, I'm Raymond Knopp. I'm president of OpenAirInterface. I can't think of a better venue to hold this event, and I'd really like to thank our colleagues and good friends here at Ericsson. Ericsson's a very special place in the world of the systems that OpenAirInterface promotes and experiments with. So I'm really looking forward to this event. The theme around AI and RAN is also something very, very interesting, something that I don't know myself very much about, and I'm encouraged, and I'm really going to be listening intently to what's being said so that I can learn some things about AI in RAN. So I hope there's lots of discussions, during the coffee breaks and in other moments during the workshop. We have many, many demos. I think this time we're very, very rich on interesting demos. I'd like to thank all the people also that came from far away. Some familiar faces now again from China. I'm very happy to see some of our colleagues again. And I think that's it. So again, thank you very much, especially to Jimmy for making this happen. And now I'd like to pass the floor to our colleagues from Ericsson.
Yes, thank you. Great to have everyone here. I think this is a great venue to do this in. As Raymond said, we will have plenty of interesting demos. I'm just going to do a few minutes of housekeeping. So during the day, there will be coffee and cake served. There will be lunch. There will be a social event during the demo session. So each of you should have 2 drink tickets in between your name tags here. If you don't, it doesn't mean that Camille doesn't like you. It just means that we had to do 100 of these in a very short time, so we might have forgot. In case you don't have any, just come see us and we'll work that out. Or you could refrain from alcohol. That's another option. I'm not one to pass over a free drink, so I'm not going to do that. Okay, toilets over there and over there. So in case you need them. Also, as you can see, we have a guest Wi-Fi here for you to use. And in case you did not sign up for the event, that's entirely fine. You're more than welcome, but we might not have ordered catering for you. So please be mindful of that, is all. Further to that, housekeeping out of the way. Please enjoy your stay with us. Please enjoy the event. I think we'll have some very thought-provoking presentations, some great demos. I'm really happy to see that we got them all sort of set up. Maybe not all of them are working yet, but that's demos for you. I'm sure they will be working by the time we get there. I'd also like to take a few moments to say welcome to us here in Stockholm. I myself, I don't live in Stockholm, nor am I from Stockholm. So I'll take this opportunity to say that maybe we should have found someone who's actually from Stockholm to welcome you here. And as another colleague pointed out, why did you volunteer to host this thing? I mean, we could have been in the south of France instead. And now we have to go to Stockholm. But as I'm from Gothenburg, second largest city in Sweden, with a well-known rivalry compared to Stockholm, some people would call it the little brother complex towards Stockholm. I'm genetically disposed not to like Stockholm. But if we keep it in this room between 100 of our closest friends, I can reluctantly tell you that it's a very nice city in the summer. So it's a shame we dragged you out from Stockholm into Kista. But Kista has the unique benefit of being our headquarters. So we have some very smart and intelligent people working here. And being in Kista means that we could invite them to participate in the event. And that we all get to interact with them, which is nice. But without further ado, I'd like to present our next speaker, a man who is a living testament to the fact that not all of our intelligent people work in Stockholm, because he's from Finland and worked there. But to be fair, you probably spent more time in Kista than most people who are actually working in Kista. So without further ado, Janne-Peisa.
Thank you. It is great to be here. I realized that I had some slides. I would need a clicker, if possible. But before that, like Jimmy said, I am not from Sweden. if there is a little brother complex between Göteborg and Stockholm, it's even bigger between Finland and Sweden. So I'm also genetically disposed to not like Stockholm or any other city in Sweden. Having said that, like Jimmy said, Stockholm is nice. Unfortunately, we are not in Stockholm. But before I start my presentation, I would also like to say that I'm a bit impressed that there is roughly 100 people here in an event that is an open source event in a telecommunication domain. Not all the telco open source initiatives have been as successful, so I think this is a sign that it's a very vibrant living community. So many people are willing to come here into Chista. And I don't think you really understand on how special place you have landed in. So Chista is fairly famous in Sweden. It's famous for being the center of the Ericsson universe. So we have all the intelligent people, we have the Ericsson top technical research here, we have a high-tech hub. But it's also known as one of the most violent and dangerous places in Sweden. So on the left-hand side of the figure, you see an actual bombing that was in the building next to this one. Well, not next to, but on the other side of the street. You can see not that bad damage, but still having a bombing in a building next to Ericsson office, it's a bit special. If you go to the southern parts of Chista, there is a mall in that direction. If you go to south of that, there is fairly frequent shootings. I mean, I say very frequent. It's not once every 10 years. It's maybe once every year. So not super scary, but still, people do die of the violence here. So it is a shame that we are not downtown Stockholm, which is nice. Be careful if you stay in Chista. If you go out, you don't want to get shot. The chances are very small, but they are bigger than they would be, for example, in Helsinki. It's safe. I have spent, like Jimmy said, I have spent here quite a lot of working days and quite a lot of nights, and have explored the nightlife of Chista. It's very convenient because it stops around 6 o'clock, so you get to bed early. And with that, I think I can go back to my presentation. So Jimmy told me that the topic of today is AI and 6G. And I thought, oh, wow, I have a chance to talk about the two most hyped topics in the telco community. And then I realized that maybe it's one hype topic and 6G. But I put together a few slides explaining what do we think of 6G and how we, from Ericsson, see the role of the AI in telecommunications, especially when moving toward next generation networks. So starting a bit with how we see 6G happening. I think the main point here is that it really is a continuous journey. So what is currently happening is that the 5G networks they are being more and more widely used. They have been deployed for quite some time, but they are now being used. We started with the initial deployments back in the 2020, and now it is 5 years after that, we are entering the phase when 5G starts to become mainstream. That also means that we are able to build on 5G, we are able to monetize 5G, we are able to build an ecosystem on 5G applications. So we are now in a journey of making 5G fulfill its full potential. And it's safe to say that the 5G has not been the revolution that it was marketed at the very beginning. So what we have seen is 5G being taken over as a complement to mobile broadband. But we have seen some new use cases. I think fixed wireless access, even though similar to mobile broadband, has really been a big success. We have seen a massive IoT, cheap devices communicating with network, electrical scooters, power meter readers and so on. So the new use cases are happening to some extent, and what we see as a 6G is then something on top of that, building on the 5G base and complementing 5G where it makes sense by having demand in network, let's say need for additional capacity, or by providing additional monetization opportunities, let's say joint communication and sensing. So 6G will be built on 5G. It's not a revolution in the sense of being completely rip and replace. It will be new in the sense that it will provide new technology, but very much founded on 5G. This is then the Ericsson vision for 6G. It really is about exploiting the full value of the network. So we have three things that we want to do with the 6G network. First one is provide added value beyond communication. Either provide information, sensing possibilities. You can use the network to actually detect the things around you, physical objects. You can provide position, you can provide timing information, you can provide other information. You can use the network to provide capabilities it has to other services. You can provide the computational capacity to end users. You can leverage the AI capabilities of network in the 6G domain as well. But the key here is really we want to build the network. A master network is built. We want to reuse these network assets for the new services. We don't want to build a new network for the new services only, because this is something we have seen from previous generations doesn't really work out. Building a network just to create integrated communications sensing system, it's not going to happen. It needs to be really built on the existing capabilities that you have in network. We want to go more than beyond being just a bit pipe. So provide opportunities for making differentiated offerings, differentiated connectivity, provide capabilities in networks of actually providing service level agreements, provide capabilities in network for providing APIs that enable software to interact with network. So having a network that actually is able to both provide information to applications, but also receive instruction from the application. This is what I like to do with that. And this, I think, is one of the things that we see happening in 5G as well. So we are providing these APIs in 5G. We want to enhance those in 6G, not replace them, but they really are sort of for providing different connectivity services and provide access to compute and AI services. And then finally, we also have of course, 6G is a new mobile broadband network, so it will be more efficient, it will be more power efficient, it will be more spectrum efficient, and it will be much more automated. What we are also seeing is that reducing the operational cost of networks is important in the 6G timeframe, making them better. So these, I think, are the three things that we are looking to do with 6G. There are some use cases in the slides. I think the main point about them is that they are very similar to 5G use cases, and they really are an extension of 5G as we know it. I will skip over this very briefly. I think what we are saying is pretty much the same message as before. We want to build on the existing network architecture. We want to build on the Open RAN paradigm. So it really is about making 6G an Open RAN native network, making it an easy to program, having the spectrum that is in the right ballpark, so in the existing ranges, and going a little bit higher in the centimeter waves, and so on. What I want to talk about is then AI mobile networks, and it is a very broad topic. So we actually created this slide fairly quickly to highlight on what are all the possible areas that are being discussed. I don't think it's actually an exhaustive list, but it at least highlights that how wide the topic really is. First, we have the AI in mobile networks. So using AI in our radio network, using AI in our core network, basically providing algorithms that are enhanced with AI. And that brings additional challenges. We need different type of data. We need different kind of processing capabilities. We need to be able to train and update our models and every now and then. So it's sort of, it's fairly complex. But here I think the gains are you are competing with academic research dating back to mid last century. So almost 100 years of academic research. So the opportunities of finding a MIMO coding scheme or even a channel coding scheme that would perform 10 times better than what we have in the literature, it's extremely unlikely. At least we haven't seen anything like that happening. So it is incremental gains. It's making sure that algorithms that we have, they are really optimized for the current operating environment. But theoretically, I think the gains are, there are gains, but they are not game-changing gains. Then we have AI used to optimize the mobile networks. And this, I think, is where there's a lot of opportunities. Currently, the networks are very complex things to manage. There's millions and millions of parameters. They all can be tuned to give a maximum performance. Everything in the network can be automated. When we are adding a new base station, you need to configure the base station. You need to configure the base station's connections to neighboring base stations. You need to change the parameters in new base station, old base station to account the new base stations being brought in. So there is a lot of opportunities for I wouldn't say highly intelligent AI. It doesn't have to be highly intelligent, but something that is capable of 24 hours a day, 7 days a week, looking at the network, finding out on how can we make it operate more efficiently. And this can be done to great extent, I think, with the help of open source. So this, I think, is one of the key dimensions where I feel AI will change the way that we actually operate our networks, by making it possible for someone to really pay attention and really help the network to perform the best that they can. Then we have hosting AI with mobile infrastructure, where we are running AI workloads in an existing infrastructure. So let's say that we have a RAN or core network, but let's say a RAN infrastructure that is built using accelerator functionality, and this is pretty much the same acceleration that we have for the AI as well. One might even say that the AI ecosystem is so much bigger than anything that we have in the mobile networks, that we could leverage the AI ecosystem to bring something into our ecosystem. And if there is this possibility of using this accelerator functionality, of course that can be then shared with other workloads. So basically the idea is to take your existing hardware, offer parts of that for other users. And I think I already saw that NVIDIA has a demo very much along those lines, so feel free to have a look at that. I think there are challenges with that approach, but I think it's very attractive because it provides additional monetization opportunities for the operators, and they are really looking for that. So I think it's an interesting development. Whether it's commercially feasible or not, I cannot say. Then we of course have the vast majority of AI applications. So let's say that you want to use ChatGPT on your phone. It will run over the mobile network. And of course you need to optimize your mobile network so that the AI applications that run on top of the network actually perform the best. So you need to optimize your network to take into account these new use cases that are relying on AI. And the ChatGPT example, I think, is a very bad example, because the traffic from ChatGPT, it will look trivially like any other internet traffic. But there can be other type of AI applications. You can have an AI agent in your phone, you can have an AI agent in your network, and they can communicate with other AI entities. They can offload their training. So there can be a significant change in the way that the network traffic looks like. And this is something we do not know yet, but it is one potential discussion point. And then finally, we have the limitations on use of AI. And especially in Europe, what we have seen is that there is a strong desire to regulate the AI. And there's a lot of discussion, quite high interest in the politician domain to make sure that AI is not hurting their voters, either by stealing their jobs or coming up with systems that completely destroy human society, like Skynet. But in general, there is a strong desire to do something. And I think these are 5 aspects that need to be considered when thinking about AI mobile networks. It's very wide. And I think I'm a bit short on time, so I will go very quickly through a few examples that I have of these areas. I don't have examples of all 5 of them. I think I have 3. So first is AI mobile networks. And what I think is clear is that every single network vendor is currently implementing AI features in their networks. So if you don't have AI features in your networks, you are not really in a game of selling mobile networks. You must have it, like in any other product. If you sell mobile phones, it must have AI features enabled. If you have an iPhone 16, it has an AI button that can turn on the AI. So it must have AI, also in mobile networks. There's also standardization activities ongoing. And this, I think, is a bit troublesome, because we are looking at very selected use cases. We are looking at network internal use cases. We are looking at the use cases that are targeting the interaction between mobile phone and network. Many of these use cases are evolving at the pace that does not meet the pace of the standardization. So there has been ongoing work in 3GPP since release 17, and release 17 is ancient in terms of AI timeframe. I'm a bit worried that the features that we specify, they may be state of the art now. By the time that we complete the specification, they will be outdated. And by the time they reach a commercial introduction, they are completely legacy. We want to do something else. So when we are focusing on AI standardization, I think it's important to focus on areas where it actually makes sense to specify things. Yes, we need data to be available. So data collection is collection of data, management of data. It's something that definitely needs to be specified, because we want to work it in a typical operator deployments that has at least a RAN and core network from different parts, and different parts of RAN from different vendors. So there is a multi-vendor need for data collection. And then we need to be able to control the mobile phones. I think this is a typical requirement from the mobile operators. They are very afraid of the performance of the network not being something that they can control. And for selected use cases, there may be a need to support some signal in network interface, but I think that's a minority. So here I will be a bit cautious, not really something that is worth standardizing, I think. Then AI to optimize mobile networks. This I think is a big domain. There's a lot of discussion. I think the key here really is that the vision that the industry has currently is that let's make it possible for operators to manage their networks by having intent-based management. So you tell the network what is your intent. Yes, you can say that your intent is to maximize the revenue that you get from the network. I don't think we are there quite yet. I think you have to be a little bit more specific that I want to be the network that provides the best throughput. I want to have the best latency. I want to have the best compromise between throughput and latency. I want to have the network that has the best coverage. You can't have all of that unless you invest very heavily in the network. So there is a lot of work ongoing trying to have an industry consensus on what kind of an intent-driven networking we are aiming to have. Lots of work going on in standards. I think here I think we have an interplay between multiple standardization organizations. It's very unclear currently on how the future product ecosystem will look like. So I think there is some benefit again on specifying the exchange of data, specifying the APIs going forward, trying to create a competitive commercial offering that can include and that can create an ecosystem for the AI companies and mobile operators and network vendors. Then the final one I had was sort of hosting AI mobile infrastructure. I think the very hot topic. You can see two different representations on the right-hand side of the picture. We have the China mobile view that they have submitted to 3GPP, where they have a different planes. They have a connectivity plane, data plane, computation plane, AI plane, security plane. And I think these are different aspects on how they can use their network beyond just providing connectivity. I'm not so sure on how to really realize these planes, but I think that fundamentally the idea is sound. The network can be used to provide additional security. The network can be used to provide AI capabilities to other applications as well. So basically leveraging the existing network infrastructure. The other one is then from NVIDIA to illustrate this compute sharing. I really like how NVIDIA is picturing the existing mobile networks as cost. And the revenue, anything that comes on top of that, I think the mobile operators would slightly disagree. I think all of their revenue is coming from this cost part, and this revenue here is something that is not yet existing. So maybe it should be additional revenue. But it is a very nice picture in the sense that it very clearly illustrates what are the opportunities. So if you have additional AI capacity in your network, you can sell that to get additional revenue. And I still strongly disagree with the cost part, but yes. Yes, then I want to flash this slide. And I think the key to take here is that AI is currently, it's being specified everywhere. So like I said, if you are selling mobile networks, you need to have AI networks. If you are specifying mobile networks, you need to work on AI. So there's a very, very wide landscape of different standardization initiatives. I think looking at all of these, I think the main message is that there are many areas that do not benefit from standardizations. We should not specify the machine learning models that are being used, not the artifacts. We don't specify training functionality. We don't want to have a separate architecture for AI machine learning. We don't want to really specify a very detailed lifecycle management for the AI objects. So basically what we want is support for data collection, data exposure, for data storage. We want to have some AI support on business critical multi-vendor interfaces, especially air interface, run core network interface, management interfaces. And we want to have some control of the AI in the network. I think that's quite good enough for standardization, but the number of initiatives, it is a little bit larger than that. And with that, I think I summarize. And like said, if you are selling networks, you must have something AI. If you are standardizing networks, you must have something AI. If you are giving AI presentations, you must have an AI-generated figure. It is the one that shows how 6C and AI connect. I'm not super impressed, but it has 6C AI. It has this nice compute dongle, so it's good. But to summarize, 6C, it's built on 5G foundation. It's not something that is fundamentally different. It's something that is fundamentally better, but built on the top of the 5G. It will focus on delivering on the journey that we are now with 5G. So how do we add things that provide additional value beyond communication? How do we do communication that is not just bit pipes, that provides opportunities for differentiation? How do we improve the existing performance? So how do we improve the data rates? How do we improve the throughput? How do we improve the operation cost? How do we reduce the energy cost? So how to make networks better? The AI is something that has a very high interest. It has an extremely high interest in standardization as well. I think there's a significant risk of overspecification. In a similar way, I would say there's a significant risk of overregulation, but I left that intentionally out from the slide so that there is no documentation of me saying that. And then we have to really look at where AI makes sense. I think it makes sense in the data management, collection, storage, exposure dimension. It makes sense in certain areas, and I think it's it really is part of the future, but hopefully something that is developed using the current momentum that we have in AI, and I think the open source has a big part of that in the future. So hopefully something exciting to talk about during these 2 days. And that, I think, concludes my presentation. Thank you.
Thank you, Janne. Are there any questions for our speaker here?
I'll start.
Please, Ian.
So, is there anything that AI cannot do? Is there anything that AI cannot do?
Yeah, I mean, if you look at the figure of 60 and AI, I'm not that impressed. So fundamentally, I think there, of course, are limitations what AI can do. I think my personal experience and opinion is that AI is very good in tasks that do not require, currently, is very good at tasks that do not require highly skilled work. So I think it does an excellent job of doing routine tasks and tasks where you are not an expert. So to give an anecdote, I'm not a very good programmer. So for me, AI is helping a lot when trying to write programs. So let's say that I want to write a Python script that goes through a .x file, extracts the XML parts of that, and reads the text from there. You can do that in ChatGPT in 20 minutes. If my other core competence is sort of finding out who are the leading companies in 3GPP. If I ask ChatGPT, it will cite me back the documents that I have published on the internet. So AI is very good in tasks that are not super complex, or are complex on different domain than your area of expertise. And in a similar way, I think in telco, there are many things that the telco engineers will do better than AI for at least for a while. And the AI will not be able to do that. But what the AI can do in the future, that I will not even speculate on. I do not know. No one knows.
Hi. Thank you for the presentation.
Could you please introduce yourself?
My name is João from Arizona State University. I'm working a lot with AI and actually ray tracing data sets. And the current channel models in 3GPP standardized are mainly stochastic, CDLs, DDLs, urban, macro. And do you see the possibility of, I mean, they are limited in terms of all the applications you can do with AI in physical layer 2. Do you see the possibility for any standardization of channel models that are perhaps more AI friendly or more general enough to fit all these AI applications that are coming up?
It's a very good question. So first, I agree with you. I mean, in 3GPP, we use stochastic models, and these stochastic models are something that we have really analyzed using the existing stochastic methods quite extensively. So the room for AI to perform better on let's say, channel coding or modulation on a wide Gaussian channel, there's no potential there. But if we would have more realistic channels, I think the AI would have more room for improvement. So I think that's a very good observation. Then I think 3GPP is a very slow-moving machine. So I think there is room for potential introducing this, but I think how it would have to work is that there would need to be some clear evidence that if we are using more advanced models, let's say ray tracing models, don't have to be AI-based, can be really ray tracing by brute force models. And then if we can then show that it's possible to obtain significant gains in those scenarios, then I think there would be an interest in 3GPP to make sure that we are not missing out on that. But I really think it's It's not yet something for 3GPP. 3GPP is it's a consensus of 700 individual members coming up from 300-400 companies. So it moves very slowly, changes very slowly. So there needs to be some external trigger, like a finding that look, if I use these ray tracing models, I can get a factor of 2 improvement in my link throughput. That I think would be sufficient for 3GPP to immediately pay attention to that.
Thank you.
Any other question? If not, let's thank the speaker. Thank you.
Thank you, and I give this to you as well.
Okay, so Ian, since you asked a very difficult question, you are on the stage next.
Oh my God. All
So, Ian is our colleague from Viavi. He's the RF and wireless architecture lead at Viavi, and he's also leading the Valor Lab that he'll speak about. Viavi is in a great place, I think, and in a very difficult place also, as we are, standardizing 6G. Not Viavi as a company, I meant. I meant you guys as
not
leading
difficult.
the testing part at ORAN also, because when something is being standardized, how do you test things? So I hope you're going to speak about that. It's a very intriguing subject and a very exciting one. So I'm looking forward to your talk, Ian.
All right.
Thanks very much.
Thank you, Irfan. Can you hear me okay? Okay. All right. So, good morning. Thanks for having me. I was a bit surprised this morning, to be honest, on Jane's slides about Chista, the very first slide. So I'm new here. It's my first time here. I would say yesterday was a great intro to the city. It was a beautiful day. And then this morning I came out walking here. I got a bit wet, but yes, it's not too bad. But I'll definitely be a bit careful walking around tonight, given the warning. Anyway, so another surprise is probably why the heck is Viavi speaking second next to Ericsson? I mean, typically we're a test company. We're usually the second to the last speaker on the last day. But thanks to Irfan, who I bribed. Unfortunately, my daughter has a graduation tomorrow. So I was the second to the last speaker, but I got bumped up. There you go. So anyway, I'm going to talk a little bit about tests. So, you saw AI, right? You saw a lot of that. We will talk about that too. Can't go through a presentation without it. But I'm going to talk a little bit more broadly as well about the other things we're doing as a company. So I do want to start out with just getting it out of the way. We're a public company. Our stock is down nowadays. So if you want to have upside in your investment, this is not bad. We're doing, 2 businesses, primarily network and service enablement. It's basically our test and measurement business. That's probably where you know us about. We test everything from fiber to wireless to operator networks, software for that as well. One thing you may not know about is we also have a business. It's a smaller part, but pretty profitable. It's called optical security. So pretty much 3D filters of these to make sure that augmented reality works. You're all actually our customers. You just don't know it. The taxes you pay basically buys the ink that is used to print the money in your wallets. So thank you. So we actually produce that as well. And we're one of the few companies that do for anti-counterfeiting ink for the paper bills that you use. So do not use Bitcoin. It's not good for us. Okay, so just quickly, we're a $1 billion company, 3,600 plus employees. Chances are, if you've interacted with a network, if you interacted with all the devices I mentioned, you've interacted with products that are tested or produced by Viavi. So what are some of the areas that we're looking into? We're a fairly diverse company. So, these are kind of, we call them our secular trends, right? Obviously, fiber is now the backbone of pretty much any network. So that's a big part of our thinking, our strategy is we want to combine fiber and wireless, in any way, shape, or form. AI obviously is a main thing. We do a lot of software for operators to improve their operations. Cloud, and then I mentioned 3D sensing. Huh? But for today, it's all about networks, right? It's all about 6G. So we all know about this kind of march, this 10-year march that we've been doing as an industry for, I don't know, the past 4 generations now, right? So we're kind of in the 5G advanced era. You start hearing about, you know, some of these networks out there that, oh yeah, we've finally deployed 5G advanced, right? And so we're kind of getting to pretty much all of 5G today. Majority is actually non-standalone, you probably know, and we're starting to kind of transition to the SA architecture, and you know, the 3GPP workshop just concluded on the next thing for 6G. And I think something that we pondered a lot, right? And I want to use this opportunity to talk to a room full of really smart people and just to poll a little bit, like, how many of you think that 6G will very much be like how 5G was in terms of industry adoption and revenue growth? I see a small handful, mostly from OAI. Okay, so of course, you know, academics and, you know, thinkers are much more optimistic, and everybody else is from industry, so I can see that. But yeah, I mean, I think, you know, we have to think about why, right? So what I did was I actually looked at the recent 6G workshop that just concluded, and I actually took exactly the words that they said in terms of 6G motivation and kind of lumped them into kind of categories. Okay, the categorization is mine. The actual words themselves are actually from the workshop, right? And I lumped a couple of things under growth, right? Again, we heard about, you know, revenue and cost. Of course, for NVIDIA, we're a cost, but that's okay, right? But there needs to be growth, right? Operators want to see new services, use cases, again, revenue growth, top line, right? We need to grow the top line as an industry. But look at the number of things that are really more about the bottom line, right? Profit, right? How do I become more efficient using AI, simplifying the network, efficiency in spectrum, energy, TCO reduction? So 5 items really on efficiency. And guess what? Engineers, okay? Finally, we talked about it a little bit, is performance, right? You see kind of this, you know, there's mostly about really improving coverage, improving service reliability, right? Remember in the early days of 5G, it was all about, I don't know, 10 gigabits per second, 100 gigabits per second. Even in the early days of 6G, it's all about 10x the throughput. I mean, we still hear that, but the mindset is changing, right? It kind of shows, in a way, the technology maturing, right? We're kind of, you know, whether we like it or not, you know, trillion-dollar companies, like NVIDIA, think of us as a cost, right? And so in a way, we need to think about the top line a little bit and also the bottom line, and think about ways on how we could really, in a way, you know, revitalize this industry. So there are a few areas that we as a company, you know, we've looked at a lot of research areas, and we kind of focus on kind of 4 aspects, at least in this talk. There's other aspects, but I want to focus on these 3. You know, mostly related around, of course, the growth part, right? Which is FR3 massive MIMO. You can think of, hey, you know, how do we really improve that throughput latency thing and coverage that they're talking about? Sensing is kind of a new revenue opportunity that a lot of operators are kind of interested and excited about. But then, you know, coverage for NTN, but AI, of course, right, is really an important topic. So I'm going to look through each of these and kind of just telling you a little bit about our strategy, which is we usually start with the research. We do the prototyping work with key partners, and then we're starting to think about the test and optimization aspects of it, which is, of course, our bread and butter. Okay, so I want to start off with massive MIMO. This is a slide I stole from a white paper in 5G America, so maybe a bit American-centric. But again, you know, new spectrum is always, in a way, the reinvigorating lifeblood for any new generation. I think it's not different really here, although you can see that there's, I would say, less strong enthusiasm about going higher and higher and higher, but it's really more about coverage, capacity, right? And extending really this sweet spot, between the FR1 and FR2, which we're calling FR3 now. And you can see here that the WRC-23 really kind of focused on the 6 to 7 gigahertz range, and there's a lot of talk about this sweet spot of 7 to 8, where we will get the nice balance of capacity and coverage. So we're pretty excited about that. I think in general as an industry, that's fairly strong consensus that this is something we want to work on. And so we've started obviously looking at this starting from the 5G era, wherein you want to do conducted tests for sure. You want to start off with how does my network perform? And we've been kind of looking at this, extending that to FR3, increasing the bandwidth, increasing the number of TRXs. But also the ORAN, right, is a big thing. We also heard that from Janne this morning. How do I test my system over the eCPRI interface? But again, let's say with 128 antennas, 256 antennas, really can't do that conducted. So over-the-air testing in a chamber, and of course early field trials. These are things that we've been kind of looking into, working on. And just a couple of partnership announcements here. We've been working with Nokia on their initial massive MIMO radio in upper 6, and we've recently expanded our Valor Lab in Arizona. We'll talk about that in the break with a actual FR3 capable MIMO OTA chamber. So if you need some facilities to do that, that's actually available for use. Okay, so that's it for FR3. I'm actually a physical layer guy for a long time, so I feel really bad that that's the end of my physical layer talk. But that's the reality, right? Like we're now going to talk about AI. Okay, we as a company, we've started looking and we've actually been looking at this technology called neuromorphic receivers. Okay, so you probably heard of a neural receiver, right? Using AI again to replace the classical signal processing that a lot of us, physical layer engineers have studied really hard, went through exams, and now they're just replacing it with a neural network. But the reality is it does provide some advantages. However, what we've seen is it actually takes a lot of energy, right? Obviously, like I don't expect to put an H100 on this guy, right, anytime soon. So so we've started looking into architectures that can really improve the energy efficiency, and we're calling this, it's not we, but the industry has called it a neuromorphic receiver, right? Really mimicking how the human brain works, right? If we have a lot of neurons, they're not firing all the time, right? They're firing parts of it. So a neuromorphic receiver, also called a spiking receiver, essentially mimics that I don't need to turn on all my neurons all the time, right? If we did that in our brains, right, we'll be out of energy by now. Right. And that's something that we're seeing, that you could actually not lose that much performance by being more energy efficient and only selectively turning on the neurons that makes sense. Okay, so this is a research work we've done with Samsung and NVIDIA as part of the AI-RAN Alliance initiative. And you would say, like, why would Viavi be doing this stuff? I mean, for us as a test and measurement company, we needed to understand where the industry is going so we can be prepared, right, to actually test them when they start kind of really putting this into product. So that's something that we've seen. It's actually a 9x energy consumption improvement without much loss in performance. So we're pretty excited about that. It's a work item now in the AI-RAN Alliance that we are leading. Just a bit about the demo. So we actually work with Samsung. So Samsung research here mostly focused on the transmit side, on the base station transmit side. It's actually not neuromorphic. This is a specialized modulation scheme they created using AI techniques, right? It's still kind of a static modulation, but they tried to answer the question, what type of constellation would be best, right? If you could design it kind of, let's call it, in this case, specifically for AWGN channels, it turns out it's actually around. So we used our neuromorphic receiver and then built it around our test bed using our friends from NVIDIA's chips. And that's something that we demonstrated at MWC. If you're interested in this, there's a video online, and we're pretty excited about it. We want more folks to use it. I mean, we're willing to work with anyone who wants to push this research more forward. Okay. All right. So that's one aspect of AI for air interface. The other one is actually combining a bit the FR3 and we saw in the 3GPP. If you were paying attention in Yanni's slide, there is 3GPP interest in using AI for beam management. That's kind of one aspect where hey, this is where AI can be useful. So this is another area. We collaborated with a institute in Singapore called I²R, essentially looking at the classical. Let's call it beam sweeping approach, right? You just scan all the beams very slow in order to find the right beam. You can cut the number of beams in half, and maybe you go faster, but it's not as precise. What if I use AI, right, with that half? It shows better performance, but what if I even know where the UE is in relation to me as a base station? Obviously, that's a great improvement that we've seen. So these are things that we're looking into and say, how can we improve beam management for FR3? We also have a demo GUI of this, and again, if you're interested in this, we could talk in the break. Okay, so and all of this is leading us to really think about what should a 6G test bed look like, right? And really for us, this is our bread and butter. This is our business, right? So we want to support the R&D of these technologies, enable the smooth migration. And so we've been looking at both our lab equipment and, by the way, our field equipment. So we also have a lot of field instruments used by operators, and in fact, our fiber equipment, how that all comes together in a 6G test bed. And some of the things we've been looking into is, again, a slightly different way of thinking about AI, but then AI to really improve test, right? So there's, of course, the classic going from functional to application emulation, capacity, performance optimization, regression. But now, with AI coming into the picture, how do we evolve test methodologies? It's something that we're thinking about, we're working with some key customers on, okay? Basically, the first thing we wanted to do is, hey, we've built up these, we understand more or less how people are using AI in terms of neural receivers, both the downlink, neural transmitter, maybe. How do I use AI to actually test AI, right? And this is kind of, we're creating data sets, we're thinking about how one who's actually developing these algorithms would need a test system to do. And I think that's something that we've been doing quite a bit of research on, and we've started creating a pretty elaborate data set, right, with diverse testing scenarios, configurations, and say, because at the end of the day, if you think about it, what AI is doing, we heard that today, right? If it's a classical channel model, right, TDL, CDL, right, AI probably is not going to shine, right? It's really about what is that very specific scenario in downtown Helsinki, right? With these number of people on this time of day, right? Is there a way that my transceiver system now or my network can do better, right? And that's really where AI could shine. So we're starting to think about what if the systems out there are doing that? How can our test bed really scale to it? But also just using AI to improve test efficiency. And we're seeing this today, right? I mean, thanks to a lot of the folks here, Ericsson, and leading vendors of the world are actually our biggest customers. And we want to improve their efficiency ultimately. Again, we heard a lot about efficiency from their customers, which are the operators, right? So we've started to think about how can I use AI to actually select the test cases that actually needs to be run, right? When you do regression, you typically have a time frame, you typically have a set of assets and say, how many can I test? And it's kind of more heuristic, more understanding of the experience, but can I use AI with this extensive data set to figure out what tests I need to run, and then of course using AI to generate those reports. So these are some things that are already in our products today initially, and then we're starting to, of course, continuing to evolve them. And then a lot of our partnership announcements here are related to our work with AI-RAN Alliance. So I talked about Valor. So we are collaborating with them. We're actually a Valor lab. As an AI-RAN Alliance lab. And so if you have some AI projects, we've been talking to some folks, members of AI-RAN Alliance, you can come in and use our facilities to do that testing. And the demo is also something that we worked on at MWC with the AI-RAN Alliance, okay? A second use case, that was more about AI for air interface. This is more AI for, let's think about it as network management, a bit higher level, right? So we've been looking at this technology called RAN scenario generation, right? You can think of it as a pretty elaborate real-time RAN simulator, right? That you could use to train algorithms, to use to test your applications. And that's kind of the, this kind of started off really with the whole RIC push from the ORAN Alliance, the RAN Intelligent Controller. But now, of course, it's not just ORAN, but pretty much any other interface that's really looking into intelligence at the network level. So we have a RAN scenario generator which can generate scenarios both terrestrial and satellite now, with now TN, NTN coming into the picture, and standardized interfaces up to some maybe centralized controller, whether it's near RT RIC, non-RT RIC, etc. So this is an area of keen interest for us. We've seen a lot of uptake from customers. They see a lot of value in not bothering with doing their own system level simulations. Like, well, what does that buy you, right? So might as well use a commercial, real time, fully tested product to be able to do these elaborate emulation scenarios and running them in real time, right, in your lab, as seen by the apps themselves. So it's called the AI RSG, and one of the most interesting use cases, and we've seen this time and time again, is energy savings, right? Operators, again, want to reduce costs, TCO reduction, energy efficiency. It's all about figuring out how to be more intelligent with the assets I have and optimizing it. So that's definitely an area of keen interest for this, using AI to improve energy efficiency in the network. So we got a few of those kind of RIC-enabled kind of announcements that we've done with Deutsche Telekom and the RIC Forum by NTIA, etc. So that's another area of AI that we think is going to be really obviously impactful. It's already impactful today. Okay, ISAC. Okay, integrated sensing and communications, you've seen a lot of different acronyms, ISAC, joint sensing and communications, JCAS, they're all, but basically at the end of the day, again, we go back to the top line, right? How can we help operators to think about monetizing their network? And guess what? Like a whole network for an entire country, isn't that just one giant big sensor, right? So like take the opportunity to sell that as a service, to maybe to prevent the first slide from Yanni's presentation, right? It's all about there's quite a bit of security, maybe surveillance, which we a bit uneasy about for sure, but yeah, whether you like it or not, the cameras are already looking at us, right? So now can we use the network as a way to really sense what's going on, beyond, just the UEs themselves, right? So for us as a testing company, we've been looking at the technology called digital twins, right? This is where you need to understand the real world. How does it look? How do the devices move? And emulate that as seen by the base station in your network, right? And so that's something that we've been looking into, testing ourselves. We've been using ray tracing as a core technology, and we've actually been developing our own ray tracing as a core technology because, again, you cannot use statistical channel models in doing ISAC. It just doesn't make sense, right? So it's really about emulating the environment, emulating the targets, whether it's monostatic, bistatic, and be able to replicate these scenarios in the lab so you can develop the right algorithms. So this is something that we started off working on on this on our own. We actually partnered with Qualcomm at MWC, where they saw our real-time ray tracer as a really good technology for them to use as well in their sensing, experiments, in the 28 gigahertz test bed. So we supported them at the MWC demo for that. Again, showing that the problem with ray tracing is it's so computationally expensive, right? And obviously our friends at NVIDIA love that, and they can sell a ton of GPUs. But we want to, again, for us, they're the cost. right? So we want to use as small a GPU as possible to run a ray tracing workload. And so that's what we've kind of been looking at, that in a server with a single GPU, not the H100s, but the one that is 2 generations earlier, right, which you can buy on eBay, can actually run a ray tracer. And I think we've started doing that. So so there you go. So that's something, and we've kind of worked on, actually our friends at Northeastern, we've kind of been doing some research with them, using AI to improve ray tracing, really lowering the computation even further by using AI. And we, I mean, I kind of talk about NVIDIA a lot. I mean, they're also a key board member of OAI. No diss to them. We're actually partnering with them. Okay. On the area Omniverse Digital Twin, we're now integrating the Omniverse Digital Twin into our RAN scenario generator, right? So that you can create much more realistic, ray tracing base. So we're actually offering up to them our expertise on the, let's call it all the layers of the stack, and we're of course using their Omniverse engine here for scenario generation. So yeah, so they're our friends. NTN is my last topic, and Irfan is coming down and about to yank me with an umbrella, but we've heard, since the 5G era, right? You've seen it actually in 3GPP. The satellite companies have been really active. They're seeing this evolution now of again, for ubiquitous coverage all around the globe, you don't really have an option, right? NTN is really the way to go, and we're seeing a lot of activity in the industry. And frankly, we ourselves were a bit surprised on the uptake of this across the whole ecosystem, and we're seeing in 6G, of course, right? And for us, it's an important technology because it touches not just our test and measurement business, but I mentioned our optical filters, optical coating. Guess what? These inter-satellite links that are using free space optics, they're actually using our optical filters today. We're supporting a lot of them in their development of these big LEO constellations you're hearing about a lot. We also have quite a bit of investment in position navigation and timing, and of course the test and measurement side of it. So it's an important technology for us to keep track of. We actually currently have let's call it really an NTN flavor of our TM500 UE emulation. And again, we were actually fairly surprised at the uptake of this. Pretty much everybody now wants to kind of understand how to build a NTN satellite base station, whatever. And again, this is a part of the industry that's really not as exposed to the mobile side, so they definitely need quite a bit of our help as an ecosystem to support that effort. Okay. And so one thing, I want to end with a test bed that of course uses OAI. You can't leave that without that. So even internally, we're actually doing some research using the OAI box, connecting our TM500, a lighter version TM Lite, and our RDA to understand. You hear a lot about this TN NTN mobility, right? So we actually have a test bed of understanding what are the key algorithms in order to enable this. So that's something that we're doing in our own labs today. And just a bit about the NTN. Again, there's a lot of effort. A lot of these satellite. One is in Japan, the other one is in Korea. Testing this technology with this actual test bed, right? We're in our TM500s on the ground. Our partners from Rohde & Schwarz is the base station side, connected through a satellite. Really, for a lot of operators, understanding what use cases can I really drive over this NTN link. Okay, so with that, Irfan, I think I'm okay on time, right?
Very good.
Okay, all right. Thank you.
Thank you, Ian. Any questions for Ian? Pamela?
Yeah, I'm Pamela Kumar. I'm from the iOS MCN organization, where we're trying to build open source using OAI and other components for private 5G. So more on your analysis of the workshop, the 6G workshop, right? And your question about whether the story is going to be as disappointing in 6G as it has been in 5G. And we have to change something, right? The vision of 5G was that it'll be all about the vertical markets, the vertical industries and the use cases. But we continue to work in the same way that we did from 1G to 4G, which was all about the telecom service providers. The telecom service providers were dominating, and we've created a network where we all communicate, and we need to keep enhancing that. But this needs to be a bunch of, you know, we need to understand each vertical industry and its use case. When I go to a vertical ministry, for instance, right? If I go to the space guys or I go to the disaster recovery agency and I want them to participate with me to do a pilot on 5G, I don't have very good access to what are those convincing use cases. And I don't think we are being driven by use cases. We always have this first slide saying it's about use cases. But then the next few slides are have nothing. Did you show me any use case driven testing? A framework? How do I create a use case, using a use case, create my whole test environment? So somewhere that's the disconnect, and I just wanted to throw that into.
Yeah, guilty. Okay, and I think a lot of us as an industry is guilty. We are engineers at heart. We like to think that we, like, you know, the famous Kevin Costner movie, build it and they will come, right? And we've done that for 4 decades, right? We built the network, the best one, latency, throughput. Well, what else can you complain about? But you're seeing we're kind of reaching a maturation, right? Like, I guess we always ask this question, like, who's complaining about not being able to watch YouTube on their phones now? Like, most of the kids today, they're fine, right? So we're reaching that point where, I mean, we are kind of unfortunately, right, a hammer looking for a nail today. We're a hammer, like, oh yeah, why don't you use 5G? Man, that's like the best thing since sliced bread. That Wi-Fi stuff, oh, that sucks. You know, you gotta use 5G. Like, it doesn't work, right? We kind of have to turn that around, right? In the sense of we need to engage them, right? And we need to really understand. And frankly, we're seeing that today. A lot of the big companies out here, they're getting people from those industries to come in to work for their companies, right? Actually experts of those industries to really understand the use case. But again, we have to stop being a hammer looking for a nail. And I must confess, even the ISAC kind of sounds like that, right? Like it's a hammer looking for a nail. But we still have to do our job, right? We still have to have the best connectivity. But yeah, I mean, I'm with you. It's all about engaging.
I would go as far as saying that the way we are structured in 3GPP, very RAN centric.
Yeah.
Right? Unless and I know that you know, when I was running TSDSI, I brought in the automotive guys. I tried to bring in the finance, fintech people, but you know, they would come to the meetings and they would say that in this whole 2-3 days meeting, there was only 15 minutes or something which was relevant to me, but I have to wait around to find when those 15 minutes will come.
Yeah.
It's not good utilization of my time.
Yeah.
And I heard the same story in 3GPP as well.
Yeah.
So
the open source folks are doing that.
Open
work, right?
source, yeah, open source is the way.
Yeah. I need
really
help from
feel
Yanni here to save me.
That true, if we can enable true open source without any constraints, okay, putting any constraints, make it Apache 2.0, pure Apache 2.0. Okay, let's not add any constraints on, and make it available, throw it into everybody's hands, and then the solutions will come. I see.
There you go. OAI.
Yes, there's a big discussion going on about that right now. That's very nice.
One more.
Any other
if
questions?
If it's possible, one more. Yeah.
Yes, please.
I already have the mic. So Stefan Valentin from Open Radio Systems, just a small startup from Germany. So I think you made many good points about the opportunities of AI in wireless and cellular. But in your opinion, how does the cost-benefit ratio look when you factor in the energy computation, the energy consumption for the training, and all the data centers that we need to build and all of that? Because of course, if I look where in the application, AI is very cheap. It's basically just a point product. But of course, getting the models is very expensive. So how would you comment on that? Does the cost-benefit ratio then look as promising as you have introduced it now?
Oh, yeah. I mean, if I were working for NVIDIA, I'd say, of course, it's worth the cost, right? But no, I think we have to think about obviously a lot of the cost comes from the training, and that's why you're seeing these huge initiatives. We're calling them like literally country-based funding, right, to build these big AI data centers to do the training. But once you've trained the models, as you said, it translates into something actually all of us now are using, right? So it becomes really consumer-centric. So this effort in AI RAN Alliance to see how do I share infrastructure, right, between the RAN and AI, I think that's one way the industry is thinking about it. But yeah, I mean, I myself, I would tell you, I am a bit of a skeptic, right, in a sense of, okay, right, what's the benefit, right? What's really the benefit of doing this? I think we're seeing this in the consumer space for sure, right? We're seeing it changing the game and really how we operate, right? We talked about the programming. I had an exact same, I haven't touched Python in a long time, and I was able to create some scripts because of programming. So there are some things that it's touching, but for RAN, as for us, there are some areas that I think it could benefit. Like Yanni kind of pointed, I kind of asked. Now the question's coming back to me.
Yeah.
So now that's
you asked the hard question.
Come around, but yeah, I think it's the high complexity. I don't really have a model for it, right? And that's really where it's good at, right? I just don't know how to model it, and I just have a bunch of data. Why don't I just throw it into AI to kind of extract some insights for me? And I think that's, things like that, like network management, we're seeing that in the operators today, right? They have tons and tons of data that they don't know how to monetize. And I think AI today, they're seeing that, hey, this can be a way to monetize that. So Irfan just gave me this, and
because we have a coffee break.
of course.
Yeah.
Oh yeah, I
Thanks
don't want
a
to
lot.
hold you for
Thanks
coffee.
for a great talk.
Right,
It was
thank
a very interesting talk. Thanks very much. Okay, so well, we are not going far anyway, but we are coming back at 11. Okay, so we have plenty of time. Okay, yeah, we love that subject. It's just we don't understand it well, but we love it. Our next speaker is Professor Tommaso Melodia. Tommaso, please let me give you the clicker. Meanwhile.
Thank you.
So Tommaso is a professor at Northeastern University, as you know well. He's one of the important figures at OpenAirInterface Software Alliance. Much of the activity that is happening in the US with our, different developments in the code base. The Northeastern team, the WIoT team is quite active there, and it's also looking at things from the next generation aspect. So a lot of contributions in things like DApps and others that Tommaso, I'm sure, is going to speak about. One other advantage of having Tommaso and later Tim also is because you guys are also very active and board members at the AI RAN Alliance. So that perspective, given the subject of the workshop, is also very interesting. So looking forward to that. Tommaso?
Thank you. Thank you, Irfan. Thanks, everyone. A great pleasure to be here again. It feels like this is a community of friends and collaborators in many ways. Are my slides? Oh, my slides. So today I'm going to talk a little bit about few ideas, thoughts about how open architectures, in conjunction with AI, will transform 6G networks, will make 6G networks from connectivity platforms to something more, cognitive ecosystems. Did I really write that? Anyway, we'll talk about that. All right. So this work is happening in the context of something at Northeastern we call Open 6G. Open 6G is a cooperative industry, university, and government R&D center that is trying to shape the future of 6G networks based on principles of open interfaces and algorithmic control and inference on the radio access network. In Open 6G, we're doing quite a bit of work on developing architectures, right? Looking at what these open architectures should look like, what can we inherit from the previous generation of open architectures, and what we should be doing differently. And also, we're trying to look at how we develop an ecosystem of testbeds as well as open source software, and from this stem our very close collaboration with the OpenAirInterface Software Alliance over the years, that can enable researchers and innovators to develop next generation concepts towards 6G. And we're also looking quite closely on algorithmic control of the radio access network, inference in the radio access network, and how we can develop principles for data collection, for generating the data sets that are going to be necessary to develop the next generation of data-driven algorithms in support of network intelligence, and how can we develop automation techniques, right? Developing pipelines that will enable us to automatically test these end-to-end networks and automatically deploy end-to-end networks based on open source software. So this has been happening for a few years at this point within the context of Open 6G. And this has stemmed from, I think, a need that is well understood by this community, the fact that we need open programmable connectivity architectures, right? 5G and beyond, the promise has been that we were going to be able to support diverse and heterogeneous use cases. This was very clear from the early days of the definition of 5G. The reality of what 5G has been a little different than that. And 6G is going to have, from the early discussions that are happening on 6G, it's going to be looking at even more heterogeneous applications that will include integrated AI and communication, integrated sensing and communications, ubiquitous connectivity, and other things. And for all of this, we need flexible and programmable network architectures that will enable providing differentiated and bespoke services for different applications. Now, the network complexity is also increasing significantly with every generation. We have diversity in terms of the devices that are connecting to our network. This is not necessarily a new thing, but it's getting to a different level. We have diversity in spectrum, right? We've had the millimeter wave being introduced in 5G, but 6G is going to, very likely, we've heard about this today, be looking at FR3, right? With the no man's land between 6 and 24 gigahertz, potentially be looking at terahertz, maybe not in the early releases of 6G. But additional diversity in spectrum and spectrum that needs to be handled in very different ways. And then diversity in terms of protocol stacks, right? Integration between wireless and wire stacks, but also integration between terrestrial and non-terrestrial networks. And all of this complexity needs to be managed, okay? We can't hope that there's going to be hundreds of engineers manually fine-tuning all of these growing, diverse stacks for specific applications. We need automation and intelligence, and we need architectures that are natively designed to support automation and intelligence that are going to be able to automate the process of managing all of this complexity, okay? Now, clearly in the last few years, there's been a lot of work that has happened in the Open RAN Alliance in looking at moving away from a traditional black box architecture to an architecture that is disaggregated with open interfaces that enable potentially different vendors to bring different parts of the RAN stack to the network, but also work looking at virtualizing the radio access network, and also work looking at opening interfaces towards abstractions that enable injecting intelligence in the network. Observing this distributed, disaggregated network at multiple levels of abstraction and at different time scales, and injecting control actions, potentially coming from third-party providers of control applications into the radio access network. And that's been the introduction of the RAN intelligent controller and the RICs, et cetera. So the architecture of the network needs to be to continue to evolve in the direction of enabling observability at different levels of abstraction and control. And we need to pair this with intelligence to be introduced in the network. Now, Irfan mentioned the AI RAN Alliance. The AI RAN Alliance is looking at various different aspects of the convergence between mobile networks and artificial intelligence. One aspect, which is something that is not necessarily new for the, I would say, for the wireless community and for the wireless industry, right, is using artificial intelligence and intelligence in general for radio access network, to improve the performance of the radio access network, to improve the spectral efficiency and other performance metrics that can include energy efficiency, etc. AI for RAN, right? Now, Open RAN and open architectures have been clearly an enabler of AI for RAN, of applying artificial intelligence to the radio access network. The observability and the openness of the architectures enables classifying what is happening in the network, looking at different traffic profiles, understanding anomalies, outages. It enables forecasting, and it enables control, right? Developing specific control applications that can provide optimized and specifically optimized services in the network, looking at things like network slicing, load balancing, etc. Now, the architecture that has been developed and defined by the ORAN Alliance with the introduction of the near real-time RAN intelligent controller and non-real-time RAN intelligent controller has been looking and leveraged in part, certainly in the research and academic community, but there's a number of applications of this that are making it into the real world today. And specifically looking at so-called RApps and XApps, control applications that act at different time scales, to control functionalities like selections of scheduling policies, slicing the radio access network, doing load balancing, etc., or longer time scale applications that can be implemented through our apps that introduce models, long-term policies in the network. Now, our group, and we think that this is something that can play an important role in the future evolution of the architectures for radio access network and of the work that is being done within the ORAN Alliance and within the AI RAN Alliance. It's also been looking at the concept of DApps, right? DApps are applications, control applications, but not only control applications, that can be executed based on abstractions that are developed on the DU component of the radio access network, on the CU component of the radio access network, or potentially even on the radio unit. So these are virtualized applications that run directly in proximity with the radio unit, the distributed unit, right? And that leverage the virtualization infrastructure of the radio access network through standardized interfaces to communicate in real time, to observe parameters in real time, and to inject control actions in real time. We also need AI native intelligent network infrastructure that will enable sensing and inference on the radio access network. And this is maybe the most important point that I'd like to make today. I talked about the AI RAN Alliance, right? And I mentioned the fact that there's a concept of so-called AI for RAN, right? AI for enhancement of the radio access network, looking at improving the performance of the radio access network. And that's one of the aspects that the Alliance is looking at. As I said, very important, but I would say a little more traditional. It's a concept that's been out there, and it's also part of the scope of what the ORAN Alliance has been doing. There's also this concept of AI and RAN that has been mentioned earlier today with this plot where RAN is a cost and AI is AI is beautiful. But I think it's an important concept, and obviously it's to be seen what will happen with that. But the idea is pretty much the following, right? If the radio access network is going to be virtualized, it will require compute infrastructure, and this compute infrastructure may be accelerated, And there's a variation over time on the amount of capacity that is needed for the radio access network. So when we dimension the radio access network, we're putting excess compute capacity for sure in the network. So can we monetize this excess capacity in the network, right? Can we use this excess capacity to provide revenue for operators that have this capillary and dense distributed infrastructure on the territory, right? And then there's a third concept, so-called AI on RAN. AI on RAN looks at AI-based applications that require or can benefit from proximity with the radio access network. Something maybe in a different area we would have called edge computing, right? But with a very specific focus on artificial intelligence applications. And I think that, honestly, and this is what I'm going to argue also in the next couple of minutes, artificial intelligence could be the edge computing applications that the telecom industry was looking for over the past few years, right? And that never really materialized as something to be really monetized in a convincing way, right? So when we talk about RAN, the classical architecture, okay, we all know what the classical architecture of the radio access network means. And I'm sure a lot of you have been following what's been happening in the last few months, right? There's been major investment, major announcements of investment on intelligent infrastructure, the Stargate announcement at the beginning of the Trump administration. Then there's been a lot of discussion happening, at least in the United States, after DeepSeek was announced on, is this huge investment on a centralized computer infrastructure really justified, right? Do you really need all that infrastructure to train models and to execute models in the network, right? But for us, what I think it's interesting to understand is that there's significant expectations, and I'm citing McKinsey and Company. They're also famous for some very remarkably incorrect predictions in terms of. But let's assume that this one is correct. They're saying 60 to 70% of AI workloads are expected to shift to real-time inference by 2030, creating an urgent need for low latency connectivity, compute, and security at the edge beyond current demand, right? Where will this edge be? Some thought leaders in AI have been also saying that most of the infrastructure cost for AI is for inference, serving AI assistance to billions of people, right? So it's not necessarily the centralized training. A lot of distributed inference will be happening, right? And does that need to be in centralized data centers that are far away from the telecom infrastructure? But also, is it only going to be assistance that will provide inference at the edge? So there's, again, looking at a lot of thought leaders in AI, been talking about so-called word foundation models, right? Foundation models that are not only able to reason and think about language in purely abstract terms, but they have the ability to think and conceptualize the physical world, right? That have information about the physics, about how objects interact with one another, about how people interact with one another, right? And that all these agents will be trained on digital twins. How are we going to create these models of the real world, right? Who is going to tell the digital twins how the real world works? Okay, so I think that there is a big opportunity for the telecom world, right? For the telco industry, and for us as a community of people that are developing the future of 6G, to look at what the role of the radio access network is going to be in the development of these world models. could 6G be the data factory of world models, right? In addition to becoming the edge inferencing layer, right? A computing infrastructure where we're gonna build the inferencing layer, right? That's clearly something that, conceptually we can do. But could we also leverage 6G to get the data that we're gonna need to create the models that are gonna help us think about the physical world, right? Now, think about what companies like Meta or the social media companies have been doing with, by just building very complex models of relationships between people just based on text, right? Or relationships. With the radio access network, we could sense what real people are doing, what objects are doing in the real world, how people communicate with one another, how close they get to one another, what they tell one another, and use this information to create models of the real world that are much more accurate. So the radio access network of 6G could be running radio access network workloads, and the run is going to be beautiful, so much better than the 5G run. But it's also going to be an important inferencing layer and a sensing layer, connecting the physical and digital world and providing low latency inference at the edge. The RAN could become a global distributed inferencing engine, but it could also be a sensing engine and a training engine. And information from the radio access network could directly go into centralized, maybe digital twins that create models of reality, right? And these models of reality could be used to train agents and distributed agents that are going to control, through the inferencing engine at the edge, the physical world, okay? So sensing through the radio access network, getting into digital twins that are used to train agents that are then executed at the edge, again, to control robots and automation in the physical world. Okay, so transforming the RAN into a global inference sensing and training engine. There's a lot of work that needs to be done in this space. Some work that we've been doing in Open6G is looking at enabling coexistence between AI and RAN on the same compute infrastructure, right? So you have accelerated compute infrastructure that looks at different workload types on different servers that will enable coexistence between AI and RAN, and dynamic context switching by means of intelligence orchestration. This is something that clearly is going to be important. Dynamic context switching between AI, sensing, and RAN, right? How do you enable smooth coexistence while respecting and complying with all of the constraints that exist for the specific application? Sensing applications have very different constraints than inferencing application. And the radio access network, well, we all know very well that it has very stringent constraints, and that needs to be very specifically optimized for the radio access network, for the hardware that it's operating on. And to conclude, I think we need to be able to build an AI native 6G that will be doing all these different things, and the logo there at the middle is not advertising, it's just a nice picture that I found. But an edge data center that will be providing these services of sensing, communication, training, and inference, maybe with an optical switched fronthaul, connecting with radio units that are distributed on the territory. Then having an intelligent orchestration layer, a RAN operating system that can take the resources that are available, match them to the needs of the users and to the applications that need to be provided, and automatically instantiate networks as well as services for sensing and inference that are going to satisfy the requests that exist on the ground based on the resources that are available. I think that a lot of this automation is going to be necessary. And one last comment on the Open RAN principles, right? however we look at it and whatever are the business goals of the various organizations that are part of this community, there isn't a single entity that can do it all, right? Nobody is today building radio access network hardware, inferencing at the edge, mobile handsets, operating systems for mobile handsets, and orchestrations and AI, right? Everybody works in an ecosystem that includes many different partners, except for maybe one vendor in a different part of the world that has it all, right? So they can build probably a very integrated AI sensing and communication stack, right? The rest of us, we need to exchange data and information with one another, right? And we need to be able to do that with open and standardized architectures and open and standardized interfaces to be able to build the next generation of models and innovate at the same pace or maybe at a faster pace of those that control the entire vertically and horizontally integrated stack. And with this, I'll give it back to you.
Tommaso, thanks for a very interesting talk. It was
Fun.
As always, very interesting. Questions for Tommaso? Sridhar? Sridhar, please introduce yourself, even though everybody knows who you are.
Hi, I'm Sridhar from Linux Foundation and also work with iOS MCN in India initiative that Pamela mentioned. My question is around for the inferencing on the edge, right? If you consider the newer hardware that's coming up, like DPUs and IPUs, do you see these kind of hardware playing role in the edge along with these RUs, doing some kind of distributed inferencing going ahead?
Yes, I think that the inferencing at the edge will be accelerated, and it will be accelerated with not necessarily with the acceleration hardware that is used today.
Okay.
And what's going to be very important, I think, is have I'm going to call it an orchestration automation layer, right, that is able to match the characteristics of the workloads to the characteristics of the hardware that is available at the edge.
Because these DPU, IPU vendors, I mean, they foresee this being growing in this edge to AI domain, mainly to support this kind of distributed inferencing.
Yeah.
Because this is basically SmartNIC, next generation SmartNIC with processing power. If I can run some kind of small models in each of these DPUs, maybe it can support the scenario. So have you come across this usage of DPUs and IPUs in any way?
We haven't been, we haven't gotten a hold of any of them.
Okay.
So far, so we've been using more.
I saw NVIDIA, I thought you would have got hold of that.
We've been using a lot of GPUs so far. Yeah.
Okay, thanks.
Ian, please.
So I'm normally an optimist, but I consider myself pragmatic optimist. Okay, so
Hammer.
So McKinsey, the 60% edge inferencing. I mean, I see that, and then I see, the near RT RIC was at one point like really exciting, and then we see a lot of operators in a way kind of shying away from that, right? In a way, there's a lot of cost involved in these edge data centers. So how realistic is that versus just putting everything in the core and just using a ton of fiber? What are really driving the latency inferencing use cases? Like, what are those inferencing that really needs that low latency?
Yeah, I think these are absolutely legitimate questions, and of course, one might. The first answer is that. In academia, we don't have to worry too much about the top line and the bottom line, and we love that. But now a little more seriously, I think again, I can't predict the future, and it's very hard to say how things will go, right? What I'm pointing out here is that there is a big opportunity, I think, and the opportunity is. The opportunity for the telco industry to try and conceptualize its evolution in support of some needs that may become more clear in the future. But I think that we have some pretty convincing evidence that they exist, right? First, if you're looking only at AI in terms of large language models, we're probably not going to have the need for latencies. That being said, there's absolutely no reason why, if you have billions of people using large language models, do we really need to centralize that, that computation to a single point, or can we distribute it, even if it wasn't for latency, right? And monetize all this compute infrastructure that will exist anyways to do that. So that's one aspect. The second aspect is that agentic AI, right, and AI in general, controlling the physical world will require much lower latencies, okay? So when you're controlling factory automations, controlling cars, controlling drones, then the latencies are going to be different than speaking with a chatbot, right? So I think that's really the area where, and that's also what I'm trying to point out. If we're just talking about large language models, well, yeah, sure, there is an opportunity, but it's the interaction with the physical world that gives us us as a telecom industry an edge, right? We have the only infrastructure that is intelligent, that has compute power, and that is completely distributed on the entire territory, right? The only other thing that is comparable that exists today is probably Tesla's. I can't think of anything else that has the same level of distribution on the territory, ability to collect data, and ability to be close and connect with the physical world. So that's.
Maybe we can take one last one. Yeah, please.
So my name is Max Stark. I'm working for NXP Semiconductors, and I have a question because here at your slide you stop at the RU, right? You stop at the G node B slide. What if kind of the McKinsey world, when they talk about edge AI, would exactly involve what you talked about, the drones, so the real interaction with the physical world, which would be on the UE side actually? How would your picture change if AI is not only located somewhere in the core network on the G node B side, but actually we need to make sure that also the edge nodes, being the robots, being the drones, being the smartphones, will have AI accelerators for an AI-enhanced UE? Right.
That's a great question. There's a nice concept of UAPs. You may not have heard about it. These are applications that run on the edge devices, on the UEs, and maybe we'll talk about that in some other conversation. But I think more seriously, we're going to have to have again abstractions on the UE side that enable algorithmic interaction between the UE stack and whatever intelligence is sitting on top of that. Interaction with the control plane, for sure, of the UE, but also interaction with the user plane. And that is a complicated issue because there is all sort of privacy, of course, issues. I think having this layer of intelligence abstraction on the UE is going to be something very important for the evolution.
Let's thank Tommaso.
Thank you.
Okay, so our last speaker before lunch, but the topic is very interesting, so I think there'd be a lot of interest in that. At our workshops, we've always had, a section where we speak about the license, the OAI license, and in general about open source licenses. We've had panels in the past. In this workshop, it's a little bit special because we have two finally presentations. There was one that Christina just gave, and now Jimmy is going to speak more about the open source license aspects. So Jimmy, he's a board member at OpenAirInterface Software Alliance for Ericsson, representing Ericsson, and he's also a longtime friend and supporter of OAI, years and years, even before Ericsson was a member. And Jimmy specializes in open source licensing policy, license policy. So he's the perfect guy to talk about this.
Yeah. So, oh, you had more slides. I didn't know you had more slides.
Here, so
Let me take us through this step by PowerPoint. Pum 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 pum.
good luck.
More slides.
I never cut my slides at the end, so okay. Good.
Here we go. Here we go. That almost caused a work injury. Okay, so I'm being rather brave doing this because I stand between about 100 people and lunch, and most of you engineers, and I'm going to talk about licenses. So, disclaimer, I'm also a lawyer by training. So this is going to be illegal, but let's try to connect it back to what Christina said earlier and why it's so important, why the OpenAirInterface license is so important, and why it really is a license designed for business, for 6G and beyond. I think sort of, Irfan, keep me honest, but at least it's like 8 years old now? Something like that, right? Yeah, so I think it stood the test of time. It has shown sort of been really remarkable in allowing sort of industry that comes from one way of thinking around patents and IP and have prior obligations to standards bodies related to FRAND to still come in and openly collaborate also on the software side in a project like OpenAirInterface. Frankly, I don't think that would be possible under a license that didn't take in those commercial realities and the sort of complexities and just the way the telco ecosystem is structured and how it works. I don't think that would be possible to have this kind of success if we weren't there. But in the first instance, why do we even need a license, right? Isn't it just good enough that we share the code? So there's going to be a little bit of a crash course in sort of legalese. No, it's not good enough that we share the code, because what you have, code is protected by copyright. Little slide here. Code is protected by many things, one of them being copyright, right? That's at the very heart of it. If we didn't have code, we wouldn't have anything, right? So code is copyrightable material, same as a novel, same as if you make a creative drawing, because coding is fundamentally very creative. So copyright is created automatically when you create a work that is copyrightable. You don't necessarily need to register it. It is transactable. I can sell you my copyright. That's what novelists do, what journalists do. They sell their copyrighted work. And that's based on the fact that it's a negative right. I have the copyright. I have the exclusive right to this, right? I can choose to grant that right under certain terms to the people I choose to do that. Either for monetary or for non-monetary compensation. But it's my choice as the copyright owner. So that's the first step. The code is protected by copyright. It's a negative right. So unless there is something telling you, yes, you are allowed to use this code, then you're not. Just because something is available on the internet doesn't mean that you're allowed to use it, right? So the second part of sort of this software thing, it's patents. And patents don't necessarily protect the specific expression of something. They protect sort of the function that the code would perform. So you can copyright, okay, I can write this in a different way. It'll be fine. I don't infringe your copyright. Patents, I can't write really, it doesn't really matter which way I write this function that the code is supposed to perform, because it would still infringe that patent, because it protects the function, right? So they're kind of implementation agnostic, and they are transactable as well. I can sell my patent, I can license my patent. As you heard with Christina Peterson talking earlier, that's an important part of how the telco ecosystem funds the future development, is that we're able to do that we're able to transact on patents. Also, another layer to this is trade secrets, and trade secrets are the things you choose to keep secret. They're not really well suited for open source because, as you know, with open source, it's not secret, it's out there, right? So you can, of course, keep trade secrets on like the stuff you build on top of open source, but for things you intend to put on open source, you're pretty much not going to have trade secret on those. And then finally, sort of in this multi-layer protection, trademarks. I know next to nothing about trademarks, so I'm not going to talk much about them. So as said, doing a little bit of comparison of licenses here. So what we have in the one end, we have the OAI license, or rather all of these licenses. They manage this copyright in slightly different ways. BSD style licenses, Apache, which is what the OAI license is based on, and GPL, which is what, for example, Linux kernel is licensed under. They all manage copyright slightly different, but fundamentally they grant you the right to study, modify, and redistribute. Same for OAI license, it gives you those rights, right? Otherwise, we wouldn't have a community around this code if we couldn't do that. Where these differ, it's sort of how we decided to manage patents. So in, for example, the BSD case, there's no explicit patent license grant. There's arguments as to if there is an implied license, if that was intended by the original authors of those licenses or not. I mean, we can probably argue until the cows come home about how that should be, and lawyers have done that, and there's been lengthy articles written about that, if there is a patent license or not. But the fact is, we probably won't know until someone litigates the matter and have that decided by a court. And that sort of actually brings us to an interesting point, which is on the bottom here, that the open source license, typically, they don't have a choice of law provision or a venue provision. And a choice of law provision is saying, well, we're going to interpret this agreement or this contract or this license according to the laws of, XYZ country. Like, could be the laws of Sweden, could be the laws of the US, could be laws of France. Or a venue provision which says we're going to use this court. If we are in disagreement, we're going to use this court. But typically, open source licenses don't have that. Again, OpenAirInterface is different, and we'll get to that part and why it's important. I would say, if we move to Apache, it does contain an explicit patent license grant for those patents that are necessarily infringed by your contributions for patents you can grant a license to. So say that I were to implement something in Apache, I don't have the patent on it, that's held by some other company. My contribution cannot bind them. They're a third party. It's not my right to give away, right? And so you have a rather small sphere. And these licenses then depend on the fact that sort of there is a community around this. You wouldn't sue into the community because you might have an own dependence on this, but they can't really extend the scope much beyond that. It's bound to sort of the fact that we're trying to create incentives not to assert your patents in this ecosystem. Again, the telco ecosystem is different. It has chosen a different way of granting this access, right? And again, the OAI license tries to manage this or manages this by referring back to those FRAND commitments. And again, it's a different way of ensuring that there is access. And in my view, it's probably a better way because it's broader. It goes back to sort of if something is standard essential, then we refer that to the established rules that we had for 30 years in, for example, ETSI, on how do we make that patented technology available. And the whole sort of body of law around that, because FRAND has been, despite the vast majority of licenses being patent licenses in the telco ecosystem being signed without litigation, there's been litigation, which is more than you can say for example, BSD, Apache, or GPL. There's been very little litigation or very little court, very little determinations in court that provides clarity. But at least with FRAND, we have a lot of clarity if we compare to that. Also, there is great clarity for academia with the OpenAirInterface license, because when that was written, one of the things that we wanted to accomplish was to ensure that for academic research, for non-commercial purposes, there was access, there was freedom, and no one should have to worry about that, right? Without sort of necessarily threatening the business model or needing to change the business model of how we fund future research, which is licensing commercial implementations of the same technology. Also, I think it's interesting because kind of due to this, the OAI license does have a provision for choice of law. It says French law. But it doesn't say which court, but at least it's French law. So it gives us some clarity on that. So all of this taken together, I mean, we've seen, like, at least in the 4G era and before that, we'd seen projects trying to implement a 5G stack under all of these licenses. I think if you look at who have managed to build a community around that, who has sort of, in my view, probably the best stack, today it's OAI. And I think large part of that is that it recognizes like the functioning of this ecosystem, how it works, that we have pre-existing commitments to standards bodies. So I think that that is a very important thing. If you want to sort of create a community around this, you need to have sort of at least some of the incumbents on board for this. And the only way to get that is by sort of recognizing that there is a commercial reality that they need to relate to. And I think the OpenAirInterface license accomplishes that by this FRAND clause, which is pretty much the only modification to that, and the choice of law is the only modification to Apache. So, provocative question, is the OAI license still fit for purpose in the 6G era? And I would say that it is. Maybe it's not perfect. Maybe there are things we could tweak. But fundamentally, the industry logic of FRAND and standard essential patents have not changed. So since that fundamental industry logic haven't changed, I still think the idea behind the OpenAirInterface public license of providing clarity for academia, of providing sort of allowing for patent-owning companies to come in and contribute without sort of necessarily damaging the revenue stream, without necessarily sort of damaging their FRAND commitment or making something that's not compatible with their FRAND commitment, allowing for that haven't changed. That fundamental idea is still sound. So is there things we could change? Yeah, because it's not perfect. Maybe for a 6G implementation, it's time to update the license. I'm saying update, not overhaul, because it's minor updates. Like some of the things that we could look, maybe some of the wording in the FRAND clause could be improved for greater clarity. There could be some minor text edits. And maybe it's time to embrace the chaos and remove the choice of law provision. It's funny because like the first thing they teach you if you do a contracting class in law school is like you need to have choice of law, otherwise you don't know how this will be interpreted and how it will be done. And I think that's a great, it's somewhat of a flaw in many open source licenses, the fact that we don't have that, because it leaves, there is this concept of forum shopping that you select the most favorable court to you. But normally that's sort of limited within sort of one legal system. With open source, that's wide open. So could litigate this anywhere under any country's laws. So for example, with BSD, it doesn't have an explicit patent license the way Apache or GPL version 3 or the OAI license would. So it's implied. Okay. So how you should read in a obligation that's implied in a contract or a license, that differs greatly between, for example, the United States and Sweden. So if I wanted a certain outcome, I would certainly look into which legal system is more favorable here. I don't think that's necessarily good for providing predictability and clarity. On the other hand, it's no successful open source license that's been adopted by more projects than one ever had that clause. I mean, Ericsson have the dubious pleasure of probably having the least successful open source license ever with the Erlang public license. That was adopted by exactly one project, and that was the Erlang project. And even that project has since moved on to Apache because it's more well understood. But that license had the provision that it was Swedish law that would apply, and it would be the municipal court of Stockholm that was the venue. I mean, if you're a lawyer, that's great. That gives you clarity. However, if you're a developer, that kind of thing is scary. You don't understand it. And even if you are a lawyer, but you're an American lawyer, then that's kind of scary because Sweden, I don't know, is that where they build the cuckoo clocks or IKEA? I don't know. Strange country, right? And I definitely don't know anything about their law. So there's probably more lawyers than there are people lawyers in the US than there are people in Sweden. So finding a Swedish lawyer then got to be really hard. So, despite the fact that we get clarity from the choice of law provision that we have in the OAI license, maybe it's time to embrace the case. Say like, we'll have to live with that. Maybe that's a way for greater adoption by more. It's not sort of good legal advice, but it's sort of maybe good ecosystem advice. But I think that's something we need to discuss, and I think sort of the ramp up to the 6G era and the 6G stack is probably the perfect time to talk about that. Let's see, did I have anything else? No. So I didn't have any further slides, at least. I still have some time, so I will sort of bother you with one more thing. Sorry. So we have this quite unique license, this quite unique community that's sort of really brought everyone on board. I think that that's something we should value and something we should treasure. And as you heard my colleague Christina before me, the fact that we can license patents in this ecosystem, and that's how it's been built, and that's fueling sort of future R&D, that's so incredibly important. And I don't think that sort of abandoning that is not a great path forward. I think rather sort of that needs to be embraced. And sort of this is something we should be proud of with this project, because it is something that's different for a reason. It's not just different because we want it to be different. We designed this to be business friendly. And I think we're accomplishing that. I think sort of the people and the companies represented in this room is a great testament to the fact that this is a very business friendly license. It's possible to implement it commercially. We see some companies over with the demos doing that. It's possible to use in research, and it's possible to do that with great clarity and sort of at the same time having some of the big incumbents on board with doing that. And it is sort of open, it's collaborative, and it does give us sort of the clarity we need to work with for a company like Ericsson to contribute into this. And as I said, I think fundamentally it's still a sound license. It's still a sound idea because the industry logic haven't changed. And if we update it, it should be minor tweaks because the fundament is still there. But with that, let's open up for questions.
Questions, comments? Sridhar? Yes, Sridhar first, and then you. Yeah, go ahead.
So, yeah. If you go to the comparison table thing, right?
Sure.
In the third row, you mentioned no clarity for academia. I mean, I'm sorry. Isn't by default all these three licenses providing very clear instructions to this academia? As a student or as a researcher, I know what to do with these licenses, right?
Do you?
Sorry?
Do you?
Of course.
Okay, so BSD, do you know exactly
I have never heard, I'm from the Linux Foundation, right?
Yep.
We use all these three licenses extensively.
Yes.
I have never heard any academia coming and ask me, hey, can you clarify this license? What can I do with this? Never, ever. Whereas any other license other than these three, there is a clarity for the academia. I thought by default setting is clarity for academia is there in these three.
Well, I should probably say that BSD doesn't really provide me any clarity either as industry.
No, from academia. So no student or a faculty has come today and said, hey, this is the BSD license.
The fact that no student or academia has come doesn't mean that there is clarity. It means that they think there is clarity. I think there's a difference.
Or can you give me an example of what clarity they're looking for?
Okay, so BSD. Do I have a patent license under BSD? If I'm an academic researcher, who do I need to talk to? Do I need to talk to someone? Do I have all the rights I need? Apache. I implement a project under Apache. Who do I talk to for a patent license? Like, is there a list? Like, I understand that I will have some of the licenses I need from the contributors. But do I need to map their contribution into this? Do I know if they're using this? Same for GPL-v2. There's no clarity, well, either for industry or academia, if there exists a patent license grant or not.
No, why would an academia do that kind of comparison? For he has to focus on his thing, right? For his non-commercial use. These three are very clear when it comes to non-commercial use, isn't it?
Raymond?
I don't agree with that. Not all universities are interested
Just one thing.
in free use of their scientific results. There are many academic and non-profit research organizations that monetize their scientific outcome, and if they do that, they cannot contribute to any of these. Sorry?
In that case, for the you bucketize still them as academia?
What do you mean packet?
I mean, categorize them as an academia, or they may be a startup within academia.
No, they could be universities. I mean, today in some countries there's very strong push for universities and research centers to actually get involved in 3GPP and generate innovation. If they're doing that, and with any of those licenses, they're throwing any possibility for monetization in the garbage.
So let me address one more thing with that. So I'm not saying these are bad licenses. They're very successful licenses. There are some very good things with them. We participate in many projects with these licenses. Do I think they're right for a RAN stack? If we put it in the context of a RAN stack for 5G or 6G or beyond, do I think those are good licenses for that? No. Do I think they provide clarity either for industry or academia? No. Do I think the OAI license provides great clarity? Yes. I saw that we had one more question.
Yeah, I'll be very quick, don't worry.
I might not be quick with my answer.
Okay, yeah, that's expected, thank you. So can we generalize this? So I think this is a great example, and I think it's now also the time where we need to push open source for 6G. Open source and maybe even the startup bubble. So my question is, will Ericsson build, or does Ericsson maybe have already a patent licensing program for open source based startups?
So that's a very interesting question. But the fact is, from a licensing perspective, open source is just another implementation. So in a sense, yes, we don't have a separate one for open source.
Okay, that is the answer I was looking for. Yeah, are you planning to build one? Maybe to push the open source and startup base of 6G?
That would have been a great question from my former colleague that was here.
Ask her.
And I would say you were very brave. A lot of brave questions from the audience, because trying to get a straight answer from a lawyer is not easy. Yeah. So, but to address your question, I don't know if that's in the works, but I don't see that there's a fundamental difference between if your business model is open source or your business model is proprietary. From a patent perspective, it's the same technology being implemented. So if we compare this to a handset, a UE, frankly, from a licensing perspective, it doesn't really matter if you give away the UE for free or if you charge money for it, if you rent it, it still implements the same technology, right? So the underlying, as I said before, FRAND is implementation agnostic to your business model. But your business model is up to you, right?
Laurent, please.
For small companies, it's not only patents now. It is all the regulation. You have to have CE marking. You have to do so many things that, in fact, small companies cannot sell anything. It's not only patents. It's all the business.
So, overregulation in EU, yes, a big problem. Overregulation elsewhere, also a big problem. That's been pointed out by, among others, our CEO. So I think we have no problem signing on that overregulation is an issue, and especially for sort of an ecosystem like ours and small startups trying to break into that. I would say patents is probably like low on that list of worries, where it should be. Any sort of last comments or questions? Otherwise, we'll head to lunch.
Navid has a question.
So thanks, Jimmy. I have like two questions.
Navid, could you please introduce yourself, especially the Bubble RAN angle?
Yes, I'm Navid from Bubble RAN and also Eurecom and also OAI board member.
You wear a lot of hats.
Yes. Two questions. Do you think OAI license is only applicable to the telco space, or is it wider than telco space? If, for instance, we look into ORAN specification, XApps, RApps, and also if we look into AI applications, right? Would OAI license still be relevant to be applied in those space, or should we keep it only at the level of 3GPP?
I think probably market experimentation is a good way to figure that out, right?
Yeah.
It's like we could definitely try to spin up projects on that. Either there's adoption or there's no adoption. I would see those things as sort of very close to the telco ecosystem and sort of included in that bubble. but there's probably room for experimentation, and either it will be successful and sort of drive, large vendors and small coming together, because that's sort of when you will have sort of any value in open source is when you have the ecosystem coming together like that. And then to do another comparable, like if you look at media coding, so like there the ecosystem fundamenta of how you fund further research in form of patent licensing, it's very similar to telco. It's also kind of part of telco because we implement those standards. But the industry fundamenta is very similar. So I think there are projects under the OAI license for implementing some of these, and they're relatively successful. I think it's a good model to apply when you have a similar industry logic of patents are needed to fund further research and to be able to invest in standardization.
Thank you. Any other last questions? Doug? Comment, I suppose.
I just want to add one slight bit of clarification there. It might muddy the water, but when we're talking about open source licenses having any grant or lack of grant with regard to patents, the only thing that the open source license is talking about is patents that are reflected in that open source code. And in most cases, I think in all of these cases, only to the portion of code that came from the contributor that has the patent.
If that contribution or that
right.
The
so
combination
I
of that
think there's a lot of misunderstanding out there. People look at the Apache license and they think, oh, I'm home free.
Yeah.
I've got Apache because it says I have a royalty-free grant to the patents.
Yeah.
When that code implements things that are defined by industry standards that have patent policies like FRAND in them, you are still obligated by every company by the patents that are implied by those underlying standards. What the OAI license enables is for companies that have intellectual property. It allows them to contribute to the open source code without fear of compromising their rights that they have by nature of being contributors to the standard. Yeah. And so for companies, organizations, universities, whomever is the IP holder, the end user or the user of the open source code is never off the hook for the patents that are implied by the underlying standards. And the other thing is, if you can build a community and bring in more companies that are IP holders and bring them in with contributions, you get more assurance, at least in what Jimmy was saying about the clarity for academia. At least the OAI license does make it clear that if you use that code, that the contributor of the code cannot have submarined a patent in there and then go sue your academic use of that code. Actually, I think it says research use, right? Doesn't it? Or is it only academic?
I mean, I should know this, but I
don't remember. I think it's research purposes.
Defined as like non-commercial.
That's what non-commercial. I believe that companies can use the code for research purposes.
Yes.
As long as they don't commercialize it also.
Yeah.
So it's clear for academia and research purposes. So I wish that there was a perfect world where for certain segments of the domain, usages could be much more clear. But the reality in the world we live in, when we have radio technology standards that are so complex and require so many billions of dollars worth of R&D to develop those radio technologies, the natural selection process in the world economy has decided that the best way to do that and have an ecosystem of products that talk together so your cell phone can work around the world is to use methods like the 3GPP system with the FRAND model that enables that kind of very expensive R&D. And it's not perfect. It's not ideal. It makes things, brings the lawyers into play. But unfortunately, I think in this domain, that's really about the best solution you're going to have. Anywhere where you get close to hardware that's massively expensive to do research and development for is going to have those kind of limitations.
And I think just one more thing before we close. So I think what we need to remember is, again, patents, it's a negative right. It's the right to exclude, say to everyone else, this is mine. No one else gets to use this. FRAND is a modification to that, saying that since it's now part of the standard, I'm willing to grant access on fair, reasonable terms, right, to that. If you look at, for example, the patent grant in Apache, you get a subset of the patents. You can't even look at who is a contributor into Apache and say, I get all their patents. No, you need to look at what did they contribute. Did that necessarily infringe their patent? And if so, yes, you have a grant to that patent. But, right, if their patent is implemented somewhere else in the code, well, you don't have a grant. So there is that sort of unclarity, and I think it's unfair to say that because it's open source, it's royalty free. That's not really a true statement, because there's definitely companies outside of this, and an example of that is all the litigation around Kubernetes currently, because we're seeing that it's a lot of patents, and some patents formerly owned by contributors to Kubernetes are being litigated.
So I think we need to step back a little and see where these licenses came from and the purpose that they've served. Pardon?
Yeah, please go ahead. Please.
Yeah. So the success in open source in technology has been Linux. Okay, let's not, I mean, that's the precursor. That's what has defined this whole world of open source, the spirit of open source and the purpose. And we saw the explosion that has happened in the IT industry because of that. So many variations, so many applications, the internet happening, right? All of that happened because of opening up the code and so much. This step jump that we are doing from 4G into the 5G, 6G and beyond world is demanding that. We are seeing that keeping it closed is not making all those applications happen that need to happen in the way that people will find it useful and that will create, meet their purpose and create business and create development in the community. By pulling it back and keeping it, keeping it closed and making all kinds of arguments for it. Okay, I invested in R&D. How many years you want to keep milking that R&D? You invested, you made profit. Okay. You had a business. Now let it, let the world use that whatever it was and move forward and advance the world and advance technology. I think we are blocking the advancement of technology by doing this.
I think we're granting access to technology, and I think it's unfair to say all of that.
You can have your code, and you can say my code. If you use my code, you pay me for it. But if somebody else writes their own code, let them contribute their own code and open it up. What's the big deal?
So, what I must say is that, OAI has, over the years, acquired some maturity in this topic. We understand the concerns because, each industry is different. That's also an important aspect. I mean, this whole idea of Linux of something, it's like, everybody wants to make Airbnb of something, Airbnb of parking. I tried that. It didn't work. Trying to be Uber of something, it just doesn't work. So, this simplistic perspective, I'm not saying it for you, but, in general, there are many people who believe that you can build a Linux of something else. It just is not. There's no guarantee that it works. You have to take the dynamics of the industry into account. And one more thing that, Sridhar presenting Linux Foundation, we have had discussions with Linux Foundation on this topic, and for several projects, in fact, Linux Foundation did accept the OAI public license to be the license under which the code for this 3GPP related technology will be accepted. OSC is, for example, a good place, Linux Foundation OSC project, ORAN software community, where there is a repo in which you can contribute code under the OAI public license. We worked on this together, right? So and it has happened in other places as well. In the case of Magma, that OAI seeded, there again we found a compromise, and Linux Foundation did compromise with us because they understood that there was dynamics of this industry were different. So, those aspects, everybody understands. At times, people have a tendency of taking this, dogmatic position. But I don't think that is the right approach. We also need to move forward, consider the specific aspects or, qualities or reasons why this industry has, in fact, evolved this way and why it's so different from the others. So that's our position at OAI.
So happy to continue the conversation over lunch, over fika, over the demos, over beer later. That's fine. I don't want to keep people necessarily any longer from lunch, but I'm just going to say I don't think open source and open standards are fundamentally opposing each other. It's different frameworks for how we collaborate on something across company borders, across academia, across company, and they're both very successful in their domains. They're both managed to find sort of how do we do this. It's all about open innovation, right? And the fundamental that if we collaborate on something, sort of it will be greater than the sum of its parts. How we make that available and how we deal with certain sort of realities, such as patents and copyrights, that's treated differently in these. But it's two systems that have co-evolved. But they're just two different flavors of open innovation. Another flavor is if I have a collaboration agreement with Qualcomm, that's also open innovation, but it's a different flavor, right? But with that said, happy to discuss this further throughout the day. There's obviously a great interest in discussing it. I don't know if it's a great interest to continue to listen to it for the rest of the audience, but that's a different question. But lunch is served up there in the Barcelona room.
Thank you, Jimmy.